We can start. Maybe good afternoon. I would like to welcome everyone to today's Work Package 2 Media Futures seminar on fairness: are algorithms a burden or a solution? First of all, I would like to thank a lot Christine Bauer. She's an assistant professor at Ulrich University in the Netherlands, and she's experienced teacher in wide spectrums of topics in computing and information systems, ranging from algorithms to adaptive to interactive systems and their research methods. Her research activities center on interactive intelligence systems. Thereby, she takes a human-centered computing approach where technology follows human and society's need. Central themes in her research are context and context adaptivity. In the recent years, she worked on context-aware recommender systems. Core interests in her current research activities are fairness and multi-method evaluations. So, Christine, please, if you can hear me, stage is yours. Please go ahead with your seminar.
Thank you for giving me the stage and inviting me for this presentation. Yeah, you have already given a nice introduction about me, but I will say some more words about me. I'm currently, everything goes wrong as it should be always, yeah. I'm currently working at Utrecht University with my team. I have two PhD students, Kalani and Maluz, working with me on the topics, and also two student assistants that are partially funded by DBG Media, so working on the news recommender field. And as you've already said, my focus is on interactive intelligent systems with context adaptivity as the core focus. And recently I work on context-aware recommender systems with a particular interest in the music sector, not only, but that's the most fun way to deal with, and also on fairness. And the combination of recommenders, music sector, and fairness is also the topic I chose for the talk today. Now, to start with, why do we need music recommendation at all? Well, when we go on the typical music platforms, we're confronted with information overload and choice overload. So on a typical online music platform, we have access to roughly 50 million music tracks, and finding the one thing that you now want to listen to, it's like searching for a needle in the haystack, which is really challenging. So we need to filter. We need to filter, and luckily we have algorithms that can help us with that. Now we have to also consider that every person is different, everybody is different, and everybody has different preferences, demands, and needs, not only in the music sector, but also what relates to music preferences. So the challenge for a recommender systems where algorithms help us in filtering the information is that we need the right information at the right time, in the right place, in the right way, to the right person. The task seems straightforward. The solution is not so straightforward. So we're still working on that. In general, we can consider recommendation, so recommending the right item to the right person at the right time, as a matrix completion problem. And that's also the case for music recommendation. So typically, we can consider the preferences of users in a matrix where we have here on the y-axis the users and on the x-axis the items. And in the music domain, we typically have we know that the person likes the item, then it's thumbs up. Although I already said we know, we don't really know, but we observe that the person listens to one item. And so we assume the person only listens to the item and they indeed like it, not if they find it really horrible. And in addition to that, we also have a lot of question marks because these are the items that the person hasn't listened to yet. So we don't have any information. And given that we have tens of millions of users and roughly 50 million of tracks, it's very likely that a person hasn't listened to all of the tracks. So it's overall a very sparse matrix. And the goal in the recommendation task is to predict what people will like based on what they've liked in the past. There are different approaches in doing so. And one basic approach, where lots of other approaches build on, that works well in the music field, is the collaborative filtering approach. Just have a small example here for you. With collaborative filtering, we compare basically users to each other and what their preferences are. So let's imagine we have two users that both listen to an album by the Beatles and an album by the Rolling Stones. So based on their preferences, they have the same preferences, they listen to the same albums, they're considered similar users. Now, the first user, in addition, also listened to Bob Dylan, and the second user hasn't listened to Bob Dylan yet. But based on the information that they're considered similar users based on their past preferences, we can assume that the second person will also like Bob Dylan. So based on this information, the album by Bob Dylan is then recommended to the second person. Of course, in reality, things are more complex because we don't only have two users and we do not only have 3 albums. So it's really complex. Now you might think, well, typically I'm using such a platform, so everything goes well. Well, but still, in many cases, it goes well and you get the recommendations that you want to have. But there are also cases where it doesn't go well. So we still have work to do to improve things, not only for single users, but for like all people that are on such platforms overall. And now you might think, well, for me, it works well. So why should I care about other people or whatever? What can happen if something goes wrong? It's only music. It's not that someone is sent to jail. It's not that there's something wrong with the health treatment and people would die and so on. Well, I summarized a bit what could happen if it's not the best ever recommendation in the music field. So on the left-hand side, I have the various stakeholders that could be affected by music recommendations. And I give some examples what could happen if a recommendation could go wrong. So for the music consumer, I assume everybody of us has at least once in their life listened to one music track. If it's the wrong recommendation, you listen to the track, well, then you have maybe 50 minutes wasted on bad music or unsuitable music for the very moment. Maybe you're even in a bad mood because it was an unsuitable song and you don't like the day at all. Things like that can happen from the consumer perspective. Now let's look on the society perspective. So considering us all together, what could happen if recommendations go wrong? Of course, we have to consider the large scale. So it's not only one recommendation that goes wrong for one user. The impact could be that overall there is a homogeneous music consumption due to popularity bias. This could be if particularly the most popular items are recommended to almost everyone. So then it would steer for the society that people listen to the very same tracks. So that would also steer the consumption. On the other hand, it could also happen that a few isolated music cultures may emerge. It's kind of called insulation. So we have a group of people that like the particular type of music and another group of people that like something completely different, and there's no connection. And especially with music, that's a thing as a society, we really talk about music a lot, and that's a thing that also brings us all together for making friendships. So that's an important aspect that we also have to consider. Now, taking the service provider perspective or platform provider, if it happens that song X is retrieved instead of song Epsilon, well, might not change a lot from the platform provider perspective, but it could also happen that all retrieval requests target one specific track. So it could cause problems in terms of channeling, reaching peaks that might be an overload for the system. For music companies, which are mainly record companies, labels, and so on, the differences on what's recommended if things go wrong could lead to shifts on the market. So we know there are three big major labels, they're called major labels, that have the large portion of the market. And if the recommendations go wrong in a way that particularly tracks by one record company would be recommended, well, this could expand a monopoly position for this one. It could also overall expand the monopoly position for all three major labels, but it could also turn into shifting things into all the minor, like the small labels, the indie labels would get a bigger market share. Then taking the artist perspective, and I made further more fine-grained distinction. First, let's consider the top of the top superstars, so those that are generally known worldwide. It could mean for such an artist that there, for instance, 1 million streams less or more than in the previous year. You might think, oh, 1 million streams, that's a lot. When we consider last year, Bad Bunny was the artist with the most streams, which was 9.1 billion streams overall. Well, then the 1 billion streams don't sound so much in comparison for the change. But still, if some artist gets more streams, they get more popular, that could also mean that they get more, or if it's going down, less advertising deals with companies. So also impacting an additional revenue stream. Now, if you consider artists that are in the long tail of the popularity distribution, so artists that are not widely well known on a global basis, it could mean, well, if I'm an artist, it could mean that my tracks get exposure in the recommendations, or they don't get exposure because the tracks are not recommended. And especially for artists in the long tail of the popularity distribution, it could mean, well, if someone might need a second foothold outside the music business or in another job in the music business, or can live as an artist with this as the main revenue stream. So you see there are lots of different things that could impact the various stakeholders. Now, when you look at music recommendation and the research that we're doing in the field, it's mainly all about recommending the right item to the right user at the right time. So the focus is on the user, being highly accurate about what the user likes. And as a side comment, maybe it's actually the focus on what we think as researchers, what users like based on what they do, but maybe it's not always reflecting what they really like, but that's a side comment. So the focus is on the user. But who takes the artist perspective in this ecosystem of different stakeholders? Well, and that's what we do now. Let's put the artist in the loop. Let's look on recommendations, what happens from the artist perspective. And that's what I'm doing in research with my colleagues, namely with Caroline Dinesen and also Andres Ferrao. Recommenders have so far been built without asking artists, without reaching out to them. And that's, in our opinion, not the right way to do it, because systems make automatic decisions that influence what users will listen to. And this in turn has an impact on artists. And we wanted to understand the impact that such algorithms have on artists. And we also wanted to know their ideas, how the ideal music recommender system should work from their perspective. So addressing our goal to have music recommenders that are fair for artists, we reached out to artists and we're having quite some interviews with artists to learn about their opinions. And in this talk, I can only present an excerpt of what we found so far, but you get an excerpt. So one aspect that we found is that the artists felt they have no control on what is shown on the platforms about them, about their tracks that they have. And they also felt like there's a fragmented presentation. So one artist said, well, there's something that I've done 10 years ago on the platform, puts the most listened tracks first, and you have to scroll down to reach the latest album. And that's particularly referring to one of the internationally wide-known platforms that has an artist page on the platform where the most listened tracks were put first. But if you have a long career in the music field, it's very likely that items that you've produced like ages ago, released ages ago, have a higher stream count, higher play count, so they were put first. Meanwhile, I luckily can tell you this has changed. They changed the interface, and now it follows a different logic. I don't know which logic, but it's no longer that the most listened track is put first, but it still resonates with that. Artists feel like they have no control what's shown on their page. And then some of the platforms also show something that's called an online radio of the band, of the artist, which is actually a playlist which is labeled with the artist's name. It's like band access radio. And one artist said, I see things there that I do not like and that I reject ideologically. Why appears band X? In this specific case, it was an artist that was strongly oriented, left-wing oriented politically. And in this online radio, there were tracks by clearly right-wing bands, and this artist was not happy at all about that, but also had no control to make any change to that. Then another aspect that I found really interesting is how to deal with like new music, new releases. One artist says, it's a campaign telling that you release more, to tell the world, hey, there's a new album, like saying, hello, I'm here. That's what they do when they have a new release. But is it shown or is it not shown in the recommendations when something new happens? And again, referring to tracks that are someone released like later, like early on, someone said, well, it's something that I have done 10 years ago. I don't know if I feel identified with it. Because people change, artists change and develop. And that's how they're represented on platforms and in the recommendations might not be any longer aligned with how they identify with themselves. So the idea is they want to be in control of what tracks are shown or what tracks and albums are shown, but also what gets promoted in the recommendations. And in general, if it's not possible that each and every artist is in control about that and can mention or can say what are the preferences, there was general agreement to put more weight on the latest releases because they see these new releases as, hello, I'm here, that's new stuff that I'm doing and I'm proud of that. And then another aspect was about, well, what's recommended steers users' preferences because people listen to that, get used to that, and want more of that. And there was actually clear consensus among the artist opinions that we interviewed against influencing users' preferences, like against deliberately influencing users' preferences, but they made one exception, namely for reaching gender balance. So that's a topic that really popped up a lot. So one artist said, in my opinion, you can't impose specific music on the users. But still, when it comes to gender balance, and there's just roughly 20 to 25% of artists are women, then someone said, well, for instance, in heavy metal music, I imagine that there aren't many female singers. Maybe we could give them more visibility, otherwise they would never be seen. And that was the point for another project we've done, or building on that, because there was such a strong opinion on gender and gender balance in the music field. So we had a look on that. And indeed, gender is in the music sector is a highly topical subject. For instance, 20% of artists in the 2020 Billboard 100 were women or gender minorities. I say only 20%. Women represent 20% of registered composers and songwriters. There are few female-fronted festival headliners, and also in general, there's little representation of Black female artists in high popularity playlists. So gender is a topic in the music sector. So we wanted to know, well, it's general, an observation in the world. It's a topic that also the artists mentioned, that they voiced as a concern. Let's have a look on what the algorithms do concerning gender, the recommender systems. What's recommended? How can we look at this from the gender perspective of artists? In doing so, we used an open data set, music listening behavior, and I call it now a typical algorithmic approach, typical in terms of we used the matrix factorization, so a form of collaborative filtering. And we looked into that, well, what does it do in terms of gender? Is it really reflected also in the data set? So we used this open data set from Last.fm, enriched it with gender information of artists from Music Brains. And that already led to a problem, because we could only consider solo artists, because what's the gender of a band? If you have any solutions to that, how to define the gender of a band, I'm listening to you. We can use the chat. We can talk about it later on. But that's a moment where we were stuck already. Another even bigger problem is that in Music Brains, but also in other databases that exist and other data sets, there's only a binary gender classification. And we know there's different forms of gender. There's a wide spectrum, but only a binary gender classification is used. And that's also why we could only use this binary gender classification with men and women. So overall, we had in the data set then 65,000 artists, solo artists, with roughly 23% women in the data set, which is actually the gender imbalance that reflects current reality in the music business. So what we've also seen on the slides before. Now, we run recommendations with these data sets, with this data set using collaborative filtering approach. And yeah, the percentage of the recommended women in the recommendations that we looked at was roughly similar to the input. So roughly 25% of the recommendations were items by women. So we could say, yeah, actually it's reproducing what we have from the input. When you have a closer look, if you look, if the tracks are recommended one by one, and that's typically what we do in music recommendation, it's not that one item is recommended to you. Typically, a person listens to several tracks, not only to one music track. So we have a ranking. And the first woman for each user, if several music tracks are recommended, the first woman appears on average on rank 7. So that doesn't mean it's always in each recommendation list or each recommendation ranking that the first woman appears on rank 7, but on average. So for some users it could be different. So it could be that for some users, the first woman appears earlier, but for others, it's even lower. But in general, on average, we can say the first woman appears in far lower position compared to the first man. Then we explored the thing, what would happen if we took different approaches? If we would make random recommendations, meaning that we just recommend random items of what we have to users, what would happen in the ranking? If it takes such a random recommendation approach, then the first woman appears on average on rank 4. So there's still that women appear later, get less exposure because the first thing we're clicking on is the first thing in the ranking and not something also like on Google. We don't go to page 10 to see what's up there, but we start in the beginning. So it's getting in terms of position better because there's the gap is not that big. Then in addition, we took approach to recommend the same most popular items in the data set that we have to everyone. And then suddenly in the ranking, it was flipped, the result was flipped. So the first woman appears on average on rank 1 and the first man appears on average on rank 3. So yeah, if we would use such an approach, this ranking result would get flipped. Now, what do we do with that? Let's look on the percentages. So if we take this typical collaborative filtering approach, roughly 25% of recommendations are women. If you take a most popular approach, 32% of recommendations were women. So a higher percentage, higher than the input, but something you could see, oh, that there could change something in the exposure. If we do not only look on artist recommendations or recommending artists, but actually looking on the track level, because an artist typically has more than one track, then we can see, well, 66% of the recommended tracks were by women. It's like, oh, wow, there's a big difference to like 25%, 32%, or having 66%. So it's even far over the, like changing the things is going over the average of 50-50, it's even having 66%. But well, that's not the end of the story. Because if we look on the unique tracks, then we find if you take a typical approach, then we have roughly 19,000 unique tracks per women. With a random approach, so random items recommended, we have 100,000 unique tracks per women. But if we take the most popular approach, so recommending the very same popular items to all users, we reduce it to a coverage of 130 unique tracks. That's not a typo, that's the result. So likely that's not the solution that we want to have featured 130 women and forget about the rest. So how can we deal with that? So overall, the observation is that we have this feedback loop. What users consume in the past, that's what's also part of the business reality, is used as an input for the recommender algorithms. That creates an output, namely the recommended items. Typically, users consume what they're recommended, leaving out a few, but typically not consuming something else. Why would you then use a recommender? So if users consume what's recommended, that's again the input for the recommender algorithms. So that creates a feedback loop. That creates that nothing will ever change. Do you want to have that or don't we want to have that? And that gets me to the point that artists see algorithms as a possible solution to address this long-standing problem of gender imbalance in the music sector. Already gave this quote with the heavy metal music, but it came with a sentence even before. So the artist said, I think there should be actions to correct some biases. The question is in which cases it should be corrected, in which not. And then giving the example with the heavy metal music where there are just a few female singers. And we were inspired by that. Let's look into what would happen if we make a simulation over several iterations. So that usually has to have a goal. And what artist suggested was to have a progressive change towards 50% gender balance, again, considering men, women in this binary conception, because otherwise the users could perceive it as something bad and leave the platform. So if we would change from today to tomorrow, changing everything completely, people may be overwhelmed, things change a lot and might not like it. So they were suggesting a progressive change. And that's where we run a simulation. And to make things short, we could break the loop, the feedback loop. Just to give some examples. In the first graph that we see here, we have on the x-axis the different iterations. So we made recommendations, it's position 3, and then we assumed that users would consume what they recommended, the top items that are recommended, and then use that as an input for the next iteration. We trained the model again, and so on. And what we did is this black dashed line on the bottom here is if we don't change anything, we just use the collaborative filtering approach that we had to begin with. And on this graph, we show the difference in the first position between men and women. And we see here, nothing ever changes. It's first women appears on the far lower rank than the first man. And we also compared it to an adaptation of this algorithm. So we took the collaborative filtering output that it would create, but then moved down men in the position by a certain number of positions where we used different lambdas. So we had putting them down by 5 positions, 10 positions, or 7 positions. And we see here, if we would change the algorithm a lot, do lots of change, putting them down 10 positions, then it would go pretty quick to have like no difference between the positions, men and women. But even in this, like in the second round, it's already flipping the thing that there is a change in the first position, that in most cases women would go first. So it would be a drastic change. With what we have here is the green line is with the changing it by 7 positions. That would in the long run lead to no difference between men and women in the average first position. Then looking at the percentages of female artists that are recommended. Again, at the bottom, the dashed line is if you don't change anything in the algorithm, nothing ever changes, or stays roughly the same over all the iterations. So that's the feedback loop. And we can see with the different versions of re-ranking that we can rather quickly change or create a change, and then it's set like it's reaching a certain level and then doesn't change anything anymore. So again, in the percentage, we see that the percentage of women could be increased with all different approaches, with stronger re-ranking more quickly, in like fewer iterations, with less re-ranking would take longer. That would address the point that it shouldn't go too quick, because otherwise users might leave the platform if it doesn't, if the change is too drastic. And then my favorite graph is the third one. The graph shows how many items have to be modified in the re-ranking, because we take the collaborative filtering approach and then intervene with that in doing the re-ranking with lambda 5, 7, or 10. And what we see in all these approaches, so no matter how far we intervene, so how many positions we put men down in this re-ranking approach, you can see that over time in the simulation, the general or the typical collaborative filtering approach already takes over the info from the new input because people change their behavior in listening to what they're listening to. So less intervention has to take place in the re-ranking over time. So, so with the time, fewer re-ranking, like fewer interventions have to be made. And that's again an indication that we can break the loop, the feedback loop. So having given you like details about the gender aspect on fairness in the music sector, still gender is only one of the many aspects of unfairness, one of the many aspects that create unequal opportunities for artists. We still need to develop an understanding of the biases and inequalities that exist. We know already gender is a big topic in the music sector, but what other biases and inequalities exist? And we also have to investigate the various facets that hinder this equal opportunity in the field, and also specifically in music recommendation. And that's overall then the essential basis that we need to have to design music recommenders in a way that give reasonable opportunities to all kinds of artists alike. And that's just for the music sector. But what about other domains? How do algorithms act in such domains? How do people act in such domains? How can we create equal opportunities, create fairness? So lots of questions still, but what I can summarize here is, yes, algorithms may amplify biases or reproduce biases, but we can also use algorithms as a chance to change the world into a direction that we as a society want to have. Thank you.